Yeah, good morning to one and all. I am Venkatesham. I am going to discuss about the atomic structure topic. In this video, I am going to explain the black body radiation. Here, black body radiation is it's one of the drawback of electromagnetic wave theory. And what is a black body first, and then we'll discuss about its Max Planck quantum theory. Right? Max Planck is a scientist, is the first scientist to explain the black body radiation, and he's proposed that there is an ideal body which can absorb the all types of radiation, which can emit all types of radiation. Such a ideal body is called as it's a black body. Such a ideal body is called as it's a black body, right? So an ideal body which can emit all types of radiation, which can absorb all types of radiation is it's a black body. So whatever the radiation emitted by this particular black body, that we can call it as it's a black body radiation. Then it is called as it's a black body radiation, right? So to understand this one, there is an and how the black body radiation is going to be produced, and whenever the particularly I am taking that one particular solid substance, if it is heated to the higher temperature, whenever this kind of black body is heated to the higher temperature, whenever this black body is heated to the higher temperature, it can emit that is in a wide range of wavelengths, right? To understand this one, there is at a different temperature and intensity of this wave, particular black body, and then particularly it's a wavelength. Wavelength is taken on the x-axis and intensity is taken on the y-axis. Intensity is on y-axis, and there is a wavelength is taken on the particularly there is a x-axis. If you plot a graph, generally this intensity will be increases as the wavelength will be increases, and then it reaches to the maximum, and then it can be further decreases, right? This is at a particular temperature T1, and if another temperature at this is also again it reaches to the maximum, and then again it decreases. So this is at a temperature T2. So from this we can observe that there is a black body can emit the different kind of wavelengths containing radiation, and in that its intensity versus wavelength, if you plot a graph, and its intensity will be keep on increasing as the wavelength is increases, and it reaches to the maximum here, and again from that after reaching the maximum, again it will be decreases. And this is at a particular temperature T1 lower temperature, and at higher temperature also again it was observed the same thing, that is as the temperature increase, as the wavelength increases, and its wave intensity also increases, and it reaches to the maximum. After reaching the maximum, again it can be further decreases. Here T2 is a higher temperature than the T1, right? So from this we can tell that there is a black body radiation. Black body here, whatever the black body can emit the radiation in the form of a small energy packet, right? Max Planck carried out so many experiments, and from that he has plotted a graph between the intensity versus its wavelength, and now from this all his experimental studies, and Max Planck is given that energy is always it can be emitted in the discrete values, and it can be emitted in the discrete values but not in a continuous manner, and generally this energy can be emitting takes place always in the discrete values but not in a continuous manner. Definitely that particular body is associated with some fixed amount of energy, or that small energy, the smallest energy packet is called as a, it's a quanta condition. And based on this and Max Planck is proposed another theory. This theory is called as a Planck's theory, or it is also called as a Planck's quantum theory, right? He has given the some important assumptions. So in that first one is each Planck's quantum theory or the Planck's theory, he has proposed some important assumptions. In that first one is each black body radiation is associated, or it can be associated with some fixed amount of energy or the definite amount of energy. Each black body radiation is associated with some fixed amount of energy. That energy is called as a radiant energy. Radiant energy. So what is mean by radiant energy? This black body radiation definitely associated with some fixed amount of energy or the definite amount of energy. Such a definite amount of energy is called as it's a radiant energy, right? So this radiant energy can be absorbed or the emitted only in the discontinuous manner, but not in a continuous manner. Whatever the radiant energy it will be there, this radiant energy is always, it can be absorption or the emission can be takes place only in the discontinuous manner, but not in a continuous manner, right? So this radiant energy definitely it is fixed for the given radiation. This radiant energy is always emitted or the absorbed always in a discontinuous manner, but not in a continuous manner. This discontinuous manner in the form of a small energy packet. Small energy packet. This small energy packet is called as a, we can call it as a quanta. This small energy packet is called as a quanta. Is smallest energy packet is called as a quanta or quantum. This quanta is definitely it is associated with some fixed amount of energy. This energy is always which is directly proportional to the its frequency of that particular electromagnetic radiation. And mathematically I can write E is equals to, E is directly proportional to nu, and remove the proportionality, you will get E equals to h nu, or E equals to EHC by lambda I can write, or even I can write even E is equals to, that is an HC nu bar also I can write. Okay, so and whenever we are using that the smallest energy packet in the case of smallest energy packet in the case of light, generally we can call it as a photon. If the smallest energy packet in the case of light, if it is there, generally we'll use that in the photon, right? And another one is fourth one is the energy absorbed or the emitted by the black body is always an integral multiple of it's in the integral multiple of its quanta, and mathematically we can write the energy absorbed or evolved by the black body is always a integral multiple of its quanta, and mathematically I can write this is an I equals to nh nu, right, where n is equals to which is in a 1 comma 2 comma 3 and so on up to n, right? So this h nu is generally is a quanta energy. Okay, so this is a Planck's theory.